Hello everyone, welcome to the circles lecture. We will discuss the complete theory of circles chapter in this lecture. In the next lecture, I'll give you problems to practice. So first of all, what is a circle? A circle is a locus of point which moves in a plane such that its distance from a fixed point is always constant. Let us see this. C is a fixed point here, and P is a point such that its distance from C should always be R. If you see, P will trace this path in the plane, and this is called as a circle. And on every point on this circle, you will see distance from C will always be R. Okay, so this is the definition of a circle. Now, standard equation of a circle. The standard equation of a circle we just derive from the definition itself. Let us say C is the point, the center. We call it as center of circle. So center is a point h comma k, and the fixed distance we call as radius. Say that is small r here, and p is some point which is a variable point, say x comma y. If p is variable, it should always satisfy the condition that cp should always be r. So p can move, but it should always be bounded by this condition that distance from c should always be r. So Cp square should be r square, x minus h square plus y minus k square is equal to r square. So h comma k will be the center and r will be the radius of the circle. So this is the standard equation of circle. So to find the equation of circle, we need center and the radius. I hope it is clear, guys. Next. Parametric form. In parametric form, we just take up coordinates in terms of some parameter, which in this case will be theta. So if x minus h square plus y minus k square is equal to r square, we can take x minus h as r cos theta, y minus k as r sin theta. You will see for every value of theta, it will satisfy the condition. So x will be h plus r cos theta, y will be k plus r sin theta. So give different values of theta, you get different points on the circle. So theta is the parameter here. Give different values to theta, you get different points on the circle. Okay, next. Next we have diametric form. In the diametric form, let us say we have n points of diameter. So x1, y1 and x2, y2 are the n points of diameter of a circle. How do you find equation of circle here? It will just be x minus x1, x minus x2 plus y minus y1, y minus y2 is equal to 0. How do we prove this thing? Let us say P is some point on the circle. Now you know the angle subtended in the semicircle is right angle. So this angle APB will be 90 degree. So if this angle is 90, we can say slope of PB into slope of PA will be equal to minus 1 because lines are perpendicular. Slope of PB will be y minus y1 over x minus x1. Slope of PA will be y minus y2 over x minus x2. The product of them will be minus 1. So when you simplify, we get the desired result. We get this thing. This is the diametric form of circle. Next, the general equation. Now, x square plus y square plus 2gx plus 2fy plus c equal to 0 is called as the general equation of circle. You see, what you have to notice here, the coefficient of x square and y square are equal, and there is no term of xy. There is no term of xy here. The center here is minus g comma minus f, and the radius is square root g square plus f square minus c. Okay, how do we say this thing all? Let us see with the help of proof. So equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. We do completion of square here. So x square plus 2gx we can write as x plus g whole square, and we have to add g square both sides. Okay, so this g square we get on the right side. Here it become x plus g whole square. Same y square plus 2fy is there. Add f square both side. We get y plus f whole square. On the right side, we get g square plus f square minus c. Now, if we compare with the standard equation, that was x minus h square plus y minus k square is equal to r square. So, if you compare these two things, you can say h will be minus g, k will be minus f, and r square will be this thing. So, r will be root of g square plus f square minus c. Okay, so this is how we get this thing finally. So this x square plus y square plus 2gx plus 2fy plus c equal to 0 represents circle with center minus g comma minus f and radius square root g square plus f square minus c. Okay, next guys. Now we discuss this is the radius square root of g square plus f square minus c. So if this is positive, it will be a real circle. If this thing is equal to 0, then radius will be 0, so it will just be a point only. The center, that's all. There is no radius there, so it will be called as a point circle. Like for example, if I say x minus 1 square plus y minus 2 square equal to 0, that is only possible when x is 1, y is 2. That will just be a point. Next, and g square plus f square minus c less than 0, there will be imaginary circle. That is not possible. For example, if you get x minus 1 square plus y square is equal to minus 4. This is not possible. Okay guys, next. How do you find equation of circle through three non-collinear points? So if we have, let us say, ABC, three non-collinear points, you can join them to make a triangle also. How do you find equation of circle passing through A, B, and C? We have various methods here. Let us say first case, vertices are given, ABC points are given. Okay, if ABC vertices are given, the coordinates of ABC are given, how do you find equation of the circle passing through them? The first method is just take general equation of circle. We discuss now x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay, in this, put all 3 points one by one. So we get 3 equation and there will be 3 unknowns, g, f, c. So when I say put the point, let us say a coordinates are 1, comma 2. So put x as 1, y as 2. We get one equation. Similarly, put B point, put C point. We get 3 equation, 3 variable. You can solve to find the GFC. That will give you the circle. Or second method, you can find circumcenter of triangle. Because if a circle is passing through ABC, it will be circumcircle. So the center of circle will be nothing but circumcenter. How can you find that? If you remember, circumcenter is point of intersection of perpendicular bisector of the sides. So find the perpendicular bisector of AB, find perpendicular bisector of BC, the point of intersection will give you circumcenter. So after you get the center of circle, you can find the distance from A, B or C, any of the point, you get the radius. This way you can find the circle also. The next one, when equation of sides L1, L2, L3 are given. Now there we have a smart method here. Rather than finding the vertices and solving them, what we can do is we can do it directly. We say, let us say circle is L1 into L2 plus lambda time L2 into L3 plus mu time L3 into L1 equal to 0. You see what we are doing here is we're taking lines pairwise. So L1, L2, L2, L3, L3, L1. Multiply one of the pair with lambda, other pair with mu. Now you will see this equation will be satisfied by all 3 points ABC. You see, if I take triangle as ABC, this line is L1, say this line is L2, This line is L3. We'll see A will satisfy line 1 and line 3. Satisfy means what? When you put A in L1, you get 0. So, similarly, if you put A in L3, you get 0. So, if I put A here, L1 will be 0, so this will be 0. L3 will be 0, so this will be 0. Again, L1, L3 both will be 0. This will also be 0. You will see that no matter what is the value of lambda and mu, this equation will satisfy A point also, B point also, C point also. So that means whatever this equation represent will satisfy, like will pass through ABC. Now this will be a second degree non-homogeneous equation. Second degree, like x square term will be there, y square term will be there, xy term will also be there, only x term will be there, only y term will be there. But this will represent circle only if coefficient of x square equal to coefficient of y square and coefficient of xy will be equal to 0. So when you solve this thing, whatever coefficient of x square you get, whatever coefficient of y square you get, equate them, and whatever coefficient of xy you get, equate to 0, we'll get the value of lambda and mu, which when you put here, you get equation of circle also. Let us see with the help of example, this third one. This thing find circumcircle of triangle having sides x plus y equal to 4, y equal to x plus 4, and y equal to 2. So just use them L1, L2 plus lambda, L2, L3 plus mu, L3, L1 equal to 0. When you use L1, no, you just bring all the terms on one side. So we write this as x plus y minus 4. L2 we can write as x minus y plus 4. L3 will be y minus 2. Okay, so L1, L2 plus L2, L3 plus L3, L1 equal to 0. Now the coefficient of x square must be equal to coefficient of y square. So coefficient of x square you can find out from here. I think come out to be just 1 only. When you multiply this, like expand this thing and all, no, you can see coefficient of x square you get from here only when you multiply with x and x. Here and here you won't get x square. And coefficient of y square that you can find out, like you get when y you multiply with this, minus y with this y and lambda outside, y with this y and mu outside. We get minus 1 minus lambda plus mu, so you get mu minus lambda equal to 2. Second, coefficient of xy should be 0. Again, you expand them. You get coefficient of xy will be basically from here you get 0. From here you get lambda. From here you get mu. So it will also be 0. So mu minus lambda is 2 and mu plus lambda is 0. You get mu as 1, lambda as minus 1. So you put here mu as minus 1, lambda as minus 1. You get the final answer. That will be equation of circle. Okay, guys, next. Now some special cases here. For a circle which pass through origin, let us say center is h comma k. So if it pass through origin, something like this will happen. Let us say A and B are the points which intersect x and y axis apart from origin. So you will see that if this is passing through origin, so radius will be OC, and OC will be nothing but root x square plus k square. So x minus h square plus y minus k square equal to x square plus k square. One more important thing here, this. You will see if this angle is 90 degree, then AB must be diameter. And if AB is a diameter, you will see like this point will come out to be 2h comma 0 and B will come out to be 0 comma 2k. Because C will be midpoint of those two, so you can easily find the coordinates of A and B. It will be 2h comma 0, 0 comma 2k. Next case, guys. A circle which is touching x-axis. So if a circle is touching x-axis, you will see its center, sorry, its radius will be nothing but y coordinate. Basically modulus of y coordinate, because distance from x-axis will be radius. That will be nothing but mod k, because k could be positive or negative. So center h comma k, radius mod k, equation will be x minus x square plus y minus k square equal to k square. Next, a circle touching both the axes. So one of the scenario is like this. Let us say in the first quadrant we have, if it is touching both the axes, then we will see this will also be radius, this will also be radius. So if I take radius as h, so this will be h, this will be h, and chord center will become h comma h. So center h comma h, radius also h, equation will be x minus h square plus y minus h square equal to h square. Next one, guys. Next, we'll discuss what kind of thing they ask for a circle and a point. First, very important point here. See, P is, let us say, a point x1 comma y1. S is circle x square plus y square plus 2gx plus 2fy plus c equal to 0. First thing we have is power of point. See, what is power of point? Power of point we can find by, we refer to this as S1. Power of point is referred to as S1. So S1 will be, you just put the point in the circle. When I say put the point in the circle, just put x as x1 and y as y1. Basically, coordinates of P you put as x and y. So x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is it now. This will be power of point S1. Now, this will also be equal to Cp square minus R square. This will also be equal to Cp square minus R square. See how. Let us say C is the center here, like we discussed, center of the circle will be minus g comma minus f, and radius will be root of g square plus f square minus c. So if we do Cp square minus R square, so P is x1, y1, find the distance Cp square, you get x1 plus g square plus y1 plus f square minus R square. You get x1 square plus y1 square plus 2gx1 plus 2fy1, and this will come out to be g square plus f square minus R square. R square will be g square plus f square minus c. When you subtract them, you get plus c only, which is nothing but S1. Okay, so S1 power of point is nothing but Cp square minus R square. Okay, Cp square is square of distance of point from center minus R square. Next, position of point with respect to circle. Now, this will be important. Many a time we'll have to see if where does the point lie with respect to circle. If it is inside or outside or on the circle. So very simple thing, we can just use the power of point. See, if it is outside, we can say the distance Cp will be more than R. You see the first position here. If P is outside, the Cp distance will obviously be more than R. And if Cp is more than R, you will see that S1 will come out to be positive. Because S1 was Cp square minus R square. So if Cp is more than R, S1 will be positive. If it is on the circle, then Cp will be equal to R, then will be S1 will be 0. If it is inside the circle, then Cp will be less than R, so S1 will be negative. Okay, so next time you have to see if point is inside, outside, or on the circle, just find the power of point. If it is positive, will be outside, is 0 on the circle, negative will be inside. I hope it makes sense, guys. Next. Maximum and minimum distance of a point from a circle, very, very important. Let us say if a point is there outside the circle, then what will be its minimum and maximum distance from any point on the circle? See, just join that with the center. Now you see the point on this extremity here, this A point will be at the maximum distance, and this point here B will point will be the minimum distance. So we can say maximum distance will be Cp plus R and minimum will be Cp minus R. Okay, for A, Cp plus R, for B, Cp minus R. I hope it makes sense. And if the point was inside, then again join this line, which the maximum will still be Cp plus R Now minimum will be this PF distance, and PF distance will basically be, we can say now will be CF minus CP. So CF will be radius, so now it will be radius minus CP. So we can just stick mod here because if point is inside, obviously CP will be less than R. So if it is outside, we can say CP plus R, CP minus R. If it is inside, it is CP plus R, but R minus CP. So you can just remember maximum will be CP plus R no matter where it is, and minimum will be mod CP minus R. So if it is outside, it will become CP minus R. For inside, it will become R minus CP. So just remember this thing. Maximum distance CP plus R, minimum CP minus R mod. Next, guys. Now we discuss about line and a circle. How would they behave and what kind of things they can ask? This is very, very important, guys. X square plus y square plus 2gx plus 2fy plus c equal to 0 is some circle given. First, we have to find the intercept made by this circle on x-axis. What do you mean by that? See, if a circle intersect x-axis at A and B, so length of AB will be called as intercept on x-axis. Let us assume the circle intersect at x1 comma 0 and x2 comma 0. So this length of AB will be called as intercept on x-axis. So the formula for this thing is 2 times square root of g square minus c. Okay, how do we get this thing? We'll prove that also. But first, just you see that AB distance will come out to be 2 roots g square minus c. If g square is more than c, the circle intersect x-axis at 2 points. Because AB will be positive, no? If g square is equal to c, AB will come out to be 0. That means the circle touches x-axis. A and B are coinciding. So we'll say circle will touch the x-axis. And if g square is less than c, you see AB will not be real there. That means circle does not meet x-axis at all. It could be like something like this. The circle is above x-axis or below x-axis, but it does not meet x-axis. Okay, see proof of this thing. We're looking for point of intersection of circle with x-axis. So I'll put y as 0. When you put y as 0, you get x square plus 2gx plus c equal to 0. Now x1, x2 are the roots, let us say. And the difference between the roots will be length of AB, no? AB will be nothing but x1 minus x2 mod. That we can say is x1 plus x2 whole square minus 4x1 x2 under root. So sum of roots here will be minus 2g and product of roots here will be c. You can put here, you get 4g square minus 4c under root. Okay, take 4 outside, you get the final result. Don't need to mug up anything here. You just see the concept. Next, guys, intersect on y-axis, almost same thing will come out to be 2 root f square minus c. Next, intercept by any random line on a circle now. First, we discuss about x-axis, y-axis. Now, if any random line is given, how do you find the intercept with the circle? Remember, this is very, very important. You can just use geometry here. How use geometry? See, find the perpendicular distance of center to the line. That is the CP distance. Now, perpendicular from center to any chord will bisect the chord. So this AP and BP will be equal. Now we have CP, we'll have radius also. Using Pythagoras, you can find the length of PB and double that, you get AB. So AB is 2PB and PB is square root R square minus CP square. Simple and effective. Next, guys. Position of line with respect to circle. Now a line could be outside the circle like this, touching the circle. In that case, we call it as a tangent. Okay, line touching the circle at one point, we'll call it as tangent. Or it could be a chord to the circle, or you can say secant. A line which cuts the circle at 2 points will be called as secant to the circle. Okay, touching at one point, tangent, intersecting at 2 points, we call it as secant. Now, how do we find out? You just find the perpendicular distance of center to the line. If it is more than radius, it will be outside the circle, so the line will not meet the circle. If it is equal to radius, it will be tangent to the circle, like in this case, no? And if CP is less than R, then it will be a chord, or you can say secant. Basically, chord is the part only between the which lies in the circle, like this part is we called as chord. The complete line we call as secant. Okay, so CP more than R outside, equal to R tangent, less than R secant, or it intersect the circle at 2 points. Now we discuss about tangents. Now tangent will be very important concept here. First of all, we'll discuss various form of tangent. First we have here slow form. X square plus y square equal to a square. Let us see a standard circle I am taking here, and a line t equal to t is y equal to mx plus c. Now if this t is tangent to circle S, then the perpendicular distance from the center to the line must be equal to radius, CP equal to a. You can see center is 0 comma 0, so find distance of 0 comma 0 to this line. It come out to be c by root 1 plus m square, must be equal to radius of circle, so c square equal to a square 1 plus m square. So c will be plus minus a root 1 plus m square. So put that here, you get y equal to mx plus minus a root 1 plus m square. This is the slope form of tangent. Why plus minus here? Because with same slope we'll always get two tangents, no, like this. With same slope we'll get two tangents. So y equal to mx plus minus a root 1 plus m square. Instead of x square plus y square equal to a square, if we have this circle x minus h square plus y minus k square equal to a square, you don't have to worry here. Whatever result we got for this, replace y by y minus k, x by x minus h. So we get y minus k equal to m times x minus h equal to plus minus root 1 plus m square. That's all. Next one, guys, the point form. Now this is very important. It will be used in many other things also. Remember, when they say you have to find equation of tangent to the circle at a particular point on the circle. Okay, at a point on the circle. Remember this. This is only for point on the circle. And we want to find tangent, we use t equal to 0. What is t equal to 0? See, when we use t equal to 0 for a point with respect to curve, let us say point is x1, y1, the curve is this x square plus y square plus 2gx plus 2fy plus c equal to 0. We replace x square by xx1, y square by yy1, x by x plus x1 by 2, y by y plus y1 by 2, and xy by xy1 plus yx1 by 2. xy will not be in the circles, but it might be helpful in other conic section like parabola, ellipse, hyperbola. So just for the sake of completion, I have given you all the points here. So if I use it on this thing, so x square will become xx1, y square will become yy1, 2gx will become g times x plus x1, 2fy will become f times y plus y1, plus c equal to 0. So this is very important, guys. Next. In parametric form, same thing we'll do here. Just x square plus y square equal to a square. You will take point in parametric form. Let us say a cos theta, a sin theta, and then use t equal to 0. So x square will become x into a cos theta. Y square will become y into a sin theta. So one a will get cancelled out. We get x cos theta plus y sin theta equal to a. And if we have x minus h square plus y minus k square equal to a square, just replace x by x minus h, y by y minus k. Same thing will be there. Next, guys, how do you find point of tangency? If let us say a tangent is given and a circle is given, how do you find the point of contact? Let's say point of contact or point of tangency. Various methods we have. First is just you can find the foot of perpendicular from center. Foot of perpendicular from center of circle to tangent will be the point of contact or point of tangency. We have one more method here. Let us say a circle is x square plus y square equal to 8 and tangent is x plus y equal to 4. I just assume that x1 comma y1 is a point of tangency or point of contact. If you say this is a point of contact, how can we write equation of tangent? We can use t equal to 0. When you use t equal to 0, you get x1 plus y1 equal to 8. Now, this is a tangent at x1, y1. This is also tangent x1, y1. So these two represent same equation. So coefficients must be proportional. So you get x1 by 1 equal to y1 by 1 equal to 8 by 4. So x1 equal to y1 equal to 2. Directly get the point of contact. Okay, so both the methods are there. Whichever you find easy, you can use that. Next. Now more points we discuss here. See, length of tangent. Length of tangent is C. This from a point P, two tangents PA, PB are drawn. Okay, CA and CB are the perpendiculars drawn from center to them. This will be radius. This will be radius. You will see both will be right angle triangles. CP will be common. You will see these two triangles will be congruent. Okay, how do you find the length of tangent PA? You can use the Pythagoras here. There will be CP square minus R square. And if you remember, CP square minus R square was S1. So length of tangent is nothing but root S1. Okay, PA, PB both will be of equal length, root S1. Now, angle subtended by a point on circle. What is angle subtended by a point on circle? Let us say P point. The angle, this APB, which in this case will be theta, like theta by 2, theta by 2, complete angle will be theta. So we'll say P subtends angle theta on circle. Okay, so angle between the tangents is called as angle subtended by a point on circle. How can we find that? See, we can just use this trigonometry here again. We say tan theta by 2 will be r by root s1. Tan theta by 2 will be r by root s1. Next, if you want to find area of triangle PAB, you can just use, we have this formula, no, half AB sine C. What is this formula? Half of product of two sides into sine of angle between them. So in this case, I can use the side PA, side PB, and sine of angle between them. So it will be half PA PB sine theta, which will become half S1 sine theta. Because PA PB both are root S1. Next, guys, circumcircle of triangle PAB. You see, PAB, if you see the triangle, will be circumcenter of that. If you see the previous figure, this, if I take CP as diameter and draw a circle, can I say A and B will lie on that because this angle is a 90 degree? So if you draw CP as a diameter, if you take CP as diameter and draw a circle, obviously A and B will lie on that. That means the circumcircle of triangle PAB is the circle with CP as diameter. The circle with CP as diameter will be the circumcircle. The center of CP will be the midpoint of, like center of circle will be midpoint of CP, and radius will be CP by 2. Next, if they ask orthocenter of triangle PAB, now this is interesting. You see, if you see this triangle PAB, you can see this line CP will basically be perpendicular in AB by symmetry, you can see. So you can see the orthocenter of this triangle must lie on the CP line only, because orthocenter is point of intersection of altitudes. So it must lie on the altitude, no? So it lies on the line CP. And we have one more property, that mirror image of orthocenter in any side of triangle lies on the circumcircle also. So we can say it must be a point on this line such that its mirror image in AB lies on the circumcircle. And which point it could be, can be C only, no? Because the only point which lie on the circumcircle on this side will be C only. That means orthocenter and C are the mirror image of each other in line AB. So if C is mirror image of H, we can say H will also be mirror image of C, no? So orthocenter of triangle PAB will be image of C in line AB. Important point, guys. Next, pair of tangents drawn from external points. This is very, very important. So from this at the outside point, we can draw two tangents. We'll discuss how do you find the equations of them. A very simple technique here, but important, guys. Now we have the point x1, y1. Okay, we have the circle also. We have to find equation of tangents. We just assume that slope of tangent is m. So y minus y1 equal to m x minus x1. Will be equation of line passing through P with slope m. And if this line is tangent to the circle, we can say distance of center to the line must be equal to radius. So distance of center to the line must be equal to radius. So find the distance is h comma k center. This is line. Find the distance. You get m into h minus x1 minus k minus y1 by root 1 plus m square equal to r. So basically we get a quadratic in r. On simplifying, we get quadratic in m. M is the variable. No, M we don't have right now. Everything else we have. So on simplifying, we get quadratic in M will with the roots say M1, M2. That will be the slopes of line PA and PP. Okay, we get a quadratic because there are two tangents. So each slope will give you one tangent. This is very, very important, guys. Next. Now, what will be director circle? Director circle is important. It is the locus of point from which two perpendicular tangents can be drawn to a curve. The director circle will be in circle also, parabola also, ellipse also, hyperbola also. What is director circle for any curve? Is the locus of point from which two perpendicular tangents can be drawn to the curve. So in this case, let us say PA, PB are two perpendicular tangents. So we can say if this is 90, this, and if I join them with center, you can see this is already 90, this is already 90, this will also be 90. So if all angles are 90 degree and the adjacent sides will also be equal, both will be radius C and CB. So for a figure where all angles are 90 and adjacent sides are equal, it must be a square. So if this is R, this will also be R, this will become root 2R. That means PC distance will always be root 2R, so PC square is 2R square. That means x minus h square plus y minus k square equal to 2R square. You can see this is again equation of circle with center h comma k again, but the radius will now be 2R square. Radius is now root 2R. Square is 2R square, no, so radius will be root 2R. So we say locus is circle with same center and root 2 times radius. Locus is circle with same center and root 2 times radius. This is very, very important for circles. It basically will be important for conic section, all of them. Okay, guys, next. Let's see one example here. From a variable point P outside circle, tangents PA, PB are drawn such that angle APB is 60 degree. Find locus of P and in center of triangle PAB. So to find locus of P and the locus of in center of triangle PAB also. See guys, if this angle PAB was 60 degree, We can say these two triangle angles will also be equal because PA equal to PB. So if this is 60, we can say others will also be 60 only then, no? So be an equilateral triangle. And in center will coincide with circumcenter. Now, suppose for equilateral triangle, all centers are same only. So first of all, if this is R and this is 30 degree, using this sine 30, we can say sine 30 will be R over CP. So this or PC. So PC will come out to be 2R because sine 30 is 1 by 2. So PC will be 2R. That means locus of P will be a circle with same center and radius will be 2R. And the midpoint of CP is supposed to be the circumcenter. And you will see if this total distance is 2R, so the midpoint will be a distance R. That means it lies in the circle itself. So locus of P is circle with center same and radius 2R, and locus of incenter of triangle PAB will be the same circle. I hope it is clear, guys. Next. Now, normals. What are normals? Normal is just any line which passes through center of circle. Because normal is usually a line which is perpendicular to tangent at the point of contact. So if this is tangent at P, the normal will be a line passing through P and perpendicular to tangent. So obviously it will pass through center of circle. So every normal passes through center of circle. So if ever they ask you to find equation of normal passing through Q, you just find the equation of Q line joining Q with the center of circle. Okay, so a question could be asked, how many normals can pass through a point then? In a plane, if you take a point, how many normals can pass through that? So options are 1, 2, 3 or infinite. So correct answer will be could be 1 or infinite. So basically A and D. How infinite? If you take center of circle, from that point, infinite normals will pass, no? Because every normal is passing through that. And if you take any other point in the plane, inside, outside, or on the circle, always only one normal will pass through that. Okay, so how many normals can pass through a point randomly selected on a plane, randomly selected in plane? Could be one or infinite. Infinite for center of circle. I hope it is clear, guys. Next, we have chord of contact. First of all, what is chord of contact? Let us say from a point P outside circle, two tangents PA and PB are drawn. So the line joining the point of contacts, that is AB, is called as chord of contact for P. And how do you find that? We find it using again T equal to 0, which we use for the tangent equation at a point form of tangent. So same T equal to 0 we have to use for this also. See the proof of that. Let us say circle is x square plus y square equal to a square, and a P is point x1 comma y1. Let us assume A is x2 comma y2, B is x3 comma y3. So now equation of PA, that will be tangent at A. We use T equal to 0 on this thing. We get x x2 plus y y2 equal to a square. Now P will lie on this line. So if you put x as x1, y as y1, it will satisfy. So x1 x2 plus y1 y2 will be a square. Similarly, equation of PB will be x x3 plus y y3 equal to a square. P will lie on that also. So x1 x3 plus y1 y3 equal to a square. Now from 1 and 2, if I make an equation here, x x1 plus y y1 equal to a square. From 1 and 2, we can say that x2 x3 will satisfy and x2 y2 will also satisfy. So this equation of line will be passing through both A and B. So this is the required line. And if you see, this is nothing but if you use T equal to 0, we get this thing. I hope it is clear, guys. The proof is just for understanding, but at the end of the day, you just need to remember what is chord of contact and how do we find that. So chord of contact is chord joining the point of contact, and how do you find it? T equal to 0. Next. Equation of chord bisected at a point. So in this case, we'll have a midpoint of chord is given. We have to find equation of chord. So P point, the midpoint of chord AB is given. We have to find equation of chord AB. And how do we find it? It's T equal to S1. What's T here? It's the same T as T equal to 0. And what is S1 here? It is same, the power of point. So see, how do we use this thing? X square plus y square equal to a square. Let us say circle. P is point x1 comma y1. So if you use T equal to 0, so we use T on this thing first. There'll be x1 plus y1 minus a square. Okay, when you use T equal to 0, bring everything on one side. So T equal to 0 will be x1 plus y1 minus a square. S1 will be the power of point, x1 square plus y1 square minus a square. So equate these two, get equation of chord bisected at point x1 comma y1. You can easily prove this thing by basically when you have the midpoint of the chord, if you join that with the center of circle, you will see the CP will be perpendicular to AB. We get the slope of AB also, we have the passing point of AB, you get the equation of AB. Okay, but you can directly use this formula T equal to S1, same thing we get. Next is product theorem. Now this is important. It says when we have multiple secants passing through a point, if you remember, secant is a line which intersect the circle at 2 points. If we have multiple secants passing through, let us say P point, and then the product of the distances of P will always be constant. So PA1 into PB1, PA2 into PB2, PA3 into PB3. Everything always will be constant. It will be equal to S1, the power of point. This is a very important thing, guys. Let us try to prove this thing. Say circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. Point P is x1 comma y1. Say a secant from P having inclination theta will have parametric coordinates as x equal to x1 plus r cos theta, y equal to y1 plus r sin theta using the parametric form of line. Now to find PA1, PB1, you put that in S. Okay, basically this is the parametric form of line. You want the point of intersection, you put this thing into the line, circle equation. When you put that, you get x1 plus r cos theta square, y1 plus r sin theta square, 2gx1 plus r cos theta, 2fy1 plus r sin theta plus c. When you simplify, you get a quadratic in r square plus 2r something plus the constant. Now the roots will be R1, R2. What will be R1, R2? Will be the distance of P from the point of intersection. So let us say R1 is PA1, R2 is PB1. So the product of roots when you find here R1 into R2 will just be C by A. In this case, C is this thing and A is 1. So product of roots you get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, which is nothing but s1. So you can see that the product of roots, basically the product of the distances, is independent of theta. So inclination could be anything. The final value will always depend just upon x1, y1, and it is just power of the point. So this is a very important tool to solve many good problems. Okay, one application of this, concyclic points. Say we have a circle which intersect x-axis at point A0, B0 and y-axis at point 0C, 0D. So what relation we have here? AB will always be equal to CD. The product of x-intercept will always be equal to product of y-intercept. You can easily prove this thing using product theorem for origin. If I take origin is a point, so let us say this is O, this is A, this is B. So x-axis will just be a secant through origin, y-axis will just be a secant through origin, and the product of distances, that is OA into OB, will be equal to OC into OD. And they both will be equal to power of point also, but that is not need to consider here. We just say OA into OB equal to OC into OD. They'll give you AB is equal to CD because OA will be A here, OB will be B here. Okay, so next time we see something like this, directly you can say product of x-intercept will be equal to product of y-intercept.
Next, equation of chords. So if we have a circle x square plus y square equal to a square, we take 2 points in parametric form, a cos alpha, a sin alpha, and a cos beta, a sin beta. The equation of AB. Okay, you know how to find a line passing through 2 points, that y minus y1 is equal to y2 minus y1 by x2 minus x1, x minus x1. If we use that on these 2 points, after simplification, we get something like this. X cos alpha plus beta by 2 plus y sin alpha plus beta by 2 is equal to a cos alpha minus beta by 2. So this, if you remember, will help you solve many problems directly. Otherwise, you'll have to find the equation there. Try to remember this thing. Similar kind of thing will come in ellipse also and hyperbola also. So then you can relate. Next, guys, the pair of tangents. So earlier also we discussed how to find equation of tangents from external point. Now, if you want the pair of tangents means like when the lines are being multiplied together, L1, L2 equal to 0. So we have a direct formula to find that also. What is that? S1 equal to T square. So S is a curve, say x square plus y square equal to a square, a circle, point P is x1 comma y1. So S1 power of point, T is the T equal to 0 thing. Now multiply S and S1 equate to T square. What we get is pair of tangents. Upon simplification, you get L1 into L2 equal to 0. The lines will be multiplied. Okay, for example, if you have like x, 2x plus y minus 3 into x plus y minus 1 equal to 0. When you multiply them, you get, like these are two lines. When you multiply them, you get pair of lines. There was a complete chapter on this thing which was later removed from the syllabus. So rarely we use them, but sometime it is helpful in some typical problems. Next, guys. Now this next is a very, very important concept. Family of circles will be helpful in very important problems. First of all, a circle through intersection of two circles. Let us say there are two circles, S1 equal to 0 and S2 equal to 0. They intersect at 2 points A and B. Now from these 2 points, how many circles can pass? See, from 2 points, we can draw infinite circles by changing the radius. You can draw as many circles as you want. So to write them all together, we have a very smart thing to do. We can say just simply S1 plus lambda S2 equal to 0, where lambda can be any real number except minus 1. You will see later what is the problem with minus 1. So here give any value to lambda, you get a different circle. Like you give different values to lambda, you get different circles, but all will be passing through A and B. So usually like one more condition will be given about that circle that we are looking for, from which you will be able to find the value of lambda. We'll discuss that with the help of example. For now, you just see this point, S1 plus lambda S2 equal to 0. See proof of this thing. How do we prove this thing? S1 plus lambda S2 equal to 0. In this equation, the coefficient of x square will be equal to coefficient of y square, and coefficient of xy will still be 0. So that means S1 plus lambda S2 will represent a circle. Now, if you put point A, S1 will be 0 because it lies in S1. S2 will also be 0 because it lies in S2. So when you put point A, it will satisfy the equation. Similarly, if you put point B, it will also satisfy the equation. That means S1 plus lambda S2 represents a circle and it passes through both A and B. So it is the circle we are looking for. Next one, guys. Circle through intersection of line and circle. If you have a circle S equal to 0 and a line L equal to 0, there also just be S plus lambda L equal to 0. Here lambda can be any real number. Same proof. If you have to find circle through 2 points A and B, what do we do here? We use the same second method again. I'll find a circle passing through AB and find a line passing through AB. The easiest circle to find will be the circle with AB as diameter. and equation of line joining AB, then use S plus lambda L equal to 0 again. We have a circle, we have a line, we are looking for those circles passing through point of intersection of these two. Next one, guys. Now this is the most important of them, circle having tangent at a point. Now family of those circles for which at a particular point a tangent equation is given. Or you can say those circles which are touching a given line at a given point. Whereas in this case, at P point, a circle is touching this L line. We have to find the circles. You can see there are infinite circles like this, up or down. But we can write all of them in terms of x1, y1, and L directly. Again, what you will remember, S plus lambda L equal to 0. What will be S here? S will be the point circle. X minus x1 square plus y minus y1 square equal to 0. And L is the given equation of tangent. Now, how do we prove this thing? See, P will satisfy S plus lambda L equal to 0, no, because P is x1, y1. If you put here, you get 0, and it will satisfy L also. So now we can say a line will be tangent to a circle if they have only one point in common. So right now in the first point we have proved that P is common to this circle and the line. P is common to both of them. Now we have to prove that there is no other point on the line which will satisfy the circle. See, for any other point on the line, L will be equal to 0. Let us say this A point. L will be 0, but S will never be 0. You see, this S equation will be 0 only for x1, y1. So S plus lambda L equal to 0 meet line at one and only one point P. That means it will be tangent at P. So this is very, very, very important concept, guys. S plus lambda L equal to 0 here also, and circle we take as point circle. Just remember this way. Next, guys, common tangents. Now, if we have two circles, there are multiple ways they can have common tangents. First is they can have four common tangents. When will that happen? When the circles will not intersect each other. And when they will not intersect each other, when the distance between the centers is more than the sum of radii. The distance between center, as you see here, is more than sum of radii. In that case, we'll have four common tangents. Two you can already see here. They're called as direct common tangent. Two will be like this. These are called as transverse common tangents. Okay, so we'll discuss both the cases. So first, four common tangents when the circles do not intersect each other. So C1, C2 more than R1 plus R2. So two tangents will be direct tangents. How do we find them? See, let us say PA1, PA2 like these. These are the direct common tangents. Same way this side also. Draw perpendicular from C1 to the first tangent, C2 to the same first tangent. You get C1A1, C2A2, and you will see this triangle PA1C1 and PA2C2 will be similar triangles. So if triangles are similar, the ratio of the sides PC1 by PC2 will be equal to A1C1 by A2C2, which is nothing but R1 by R2. A1C1 is R1, A2C2 is R2. So if PC1 by PC2 is equal to R1 by R2, we can say P divides C1, C2 in R1 ratio R2 externally. So this we can find P point. We'll have both the circles. So you can say P is the point which divides C1, C2 in R1 ratio R2 externally. Now when you get coordinates of P, then you can use the P to find equation of tangents. We have discussed previously, how to find tangents from external point. So using that, you can easily find equation of tangents. Now, the length of direct common tangent, this is important. What is the length of direct tangent? This is like A1, A2, the distance between their point of contacts. How do you find them? See, from this C1 point, draw perpendicular on this line C2, A2. Now, this is 90, this is 90, this is 90, so this will become a rectangle. So C1, A1 will be equal to A2D. And this is R1. This will also become R1. So we can say this will become R2 minus R1. And A1, A2 will be equal to C1D. And how do you find C1D? We can use Pythagoras here. We can say C1D square will be equal to C1 C2 square minus R2 minus R1 square. So finally, the length of direct tangent comes out to be square root of C1 C2 square minus R2 minus R1 square. This is important, guys. Directly, we have to use this formula in many good problems. Okay, next. Next, we have transverse tangents. In this case, the tangents look something like this. And again, you will see the, like, if you draw perpendicular here, draw perpendicular here, the triangles will come out to be similar again, these two triangles. Triangles will come out to be similar. So TC1A1 will be similar to triangle TC2A2. So TC1 by TC2 will be A1 C1 by A2 C2. Again R1 by R2. Now T divides C1 C2 in R1 ratio to R1 ratio R2 internally. So in direct tangents externally and in transverse tangents internally. Again, you can use T to find equation of tangents as we discussed previously. Now the length of transverse tangents, this A1, A2, the distance between point of contacts. How do you find that? Again, you just extend the line and draw perpendicular from C1. Again, it will come out to be a rectangle. So A1, A2 will be equal to C1D. And if you see this right angle triangle, this is C1, C2, and this will now become R1 plus R2. Because this is R2, this will be R1. This and this will be equal. So now you can find this C1D again using Pythagoras theorem. So C1 plus C2 whole square minus R1 plus R2 square. So you can see that in direct tangent it was R2 minus R1 square. Now it is R1 plus R2 square. So almost same thing, just slight difference. Remember the formula, guys. It will be very helpful. Next one. Now next case. Next case is three common tangents. When will they have three common tangents? You can see in the figure. When they touch each other externally. So circle S1 equal to 0, circle S2 equal to 0. How will they touch each other externally? When distance between center is sum of radii. You can see there. Distance between center is sum of radii. In that case, there will be two direct tangents, which you can find using same way, like we discussed earlier. And there will be only one common tangent. That common tangent will be at the point where they touch each other. Where the circles touch each other, at that point we'll have a common tangent. How do you find that? It will just be S1 minus S2 equal to 0. Because S1 minus S2 equal to 0, when you do, basically x square y square term will get cancelled out. It will represent a line which will be meeting both the circles at common point only. There will be no other point where it will meet. So we can safely say it will be tangent at that point. Okay, one more important thing here. The length of direct tangent here. The formula I told you was C1 C2 square minus R1 minus R2 square under root. In this case, C1 C2 is R1 plus R2. So you get R1 plus R2 square minus R1 minus R2 square. When you simplify, you get 2 root R1 R2. This will also be important in many problems when the circles touch each other. For the length of direct tangent, I'll just use this formula directly, 2 root R1 R2. Okay, guys, next. Next, we have two common tangents. When will they have two common tangents? When the circles intersect each other at 2 points. As you can see here, in this case, only two direct tangents will be there, which you can find using the same way we discussed earlier. And in this case, the line joining the point of intersection is called as common chord. The line joining the point of intersection of circle is called as common chord. How do you find that? Again, S1 minus S2 equal to 0. So if they touch, it gives you common tangent. If they intersect, it will give you common chord. Same logic you can use. S1 minus S2 will be a line which will satisfy A and B both. Next, how will they have only one common tangent? When the one circle is inscribed in the, or you can say one circle is touching other internally, like in this case. The relation will be the difference, sorry, the distance between centers will be equal to difference of radii. In the previous case, how do we say that they intersected 2 points? The distance between centers is less than sum of radii, but more than difference of radii. Why more? Because if it is equal, they will touch each other internally. And how do you find common tangent in this case? S1 minus S2 equal to 0. Same logic. And when do they have no common tangent? When one circle is inside the other. In that case, the distance between centers will be less than difference of radii. In this case, there will be no common tangent here. Okay, next guys. Next is angle between two circles. First of all, what is angle between two circles? It is the angle between the tangents at the point of intersection. Let us say this is the point of intersection of the circles, and you draw tangent 1 for the first circle, tangent 2 for the second circle. This angle between the tangents is called as angle between circles. As you can see here, is alpha here. Okay, now if I draw perpendicular from C1 to this tangent, this angle will be 90, this angle at this side also will be 90. So if I see this, the remaining angle here. Okay, just to make the things more clear, I put the tangent up to this point only. Okay, so this is the red lines are the tangents, then the yellow lines are the lines joining centers. So this is alpha, this is 90, this is 90, so this remaining angle will be pi minus alpha. Now we have to find alpha angle and just join this triangle. Let us say this point was P point, the point of intersection of circles. So this is PC1, which is R1, PC2, which is R2. Alpha is the angle between tangents, and this angle is pi minus alpha. How do you find this pi minus alpha? We can use cosine rule. It says cos pi minus alpha will be R1 square plus R2 square minus C1 C2 square by 2 R1 R2. If you don't know this thing, you can just check with me in the class. What is cosine rule? Cos pi minus a will be R1 square plus R2 square minus C1 C2 square by 2 R1 R2. So from here you can find the value of alpha easily. Now, special case, when alpha is 90 degree, we call them as orthogonal circles. If alpha is 90 degree, we call them as orthogonal circles. In that case, you see this cos, this will become cos 90, which will be 0. So the numerator must be 0. So you get R1 square plus R2 square is C1 C2 square. You can see in that case, this triangle will be right angle triangle. Okay, so R1 square plus R2 square will be C1 C2 square. Now this is the geometrical result, but theoretical result we use more. Let us say there are two circles, x square plus y square plus 2gx plus 2fy plus c equal to 0. Second circle is x square plus y square 2g1x plus 2f1y plus c1 equal to 0. Now this says r1 square plus r2 square equal to c1 c2 square. So r1 square you can find here g square plus f square minus c. R2 square will be g1 square plus f1 square minus c. The centers you know how to find the distance in the centers. Upon simplification, you get 2g1 plus 2ff1 equal to c plus c1. This is a very important result. Many problems will solve using this thing. So if two circles are orthogonal, you have to remember two things here. First, r1 square plus r2 square will be c1 c2 square, and second, 2g1 plus 2ff1 will be equal to c plus c1. This GFCR from the general equation of circle. Okay, I hope it is clear, guys. Next, radical axis. Now, this concept is as such not in the syllabus, but is helpful to solve many problems. So we'll discuss this thing also in detail. What is radical axis? It's the locus of point from which tangents drawn to two circles are of equal length. Let us say this is a point P and the tangents PA and PB are drawn. So according to definition, length of PA will be equal to length of PB. So S1 is the first circle, S2 is the second circle. So how do you find the length of tangent? If you remember root S1, this will be root S2. So root S1 equal to root S2, square both side, S1 equal to S2. So what do you get from here? S1 minus S2 equal to 0. So exact same equation like we got for the common tangent and the chord of quadrant, so the common chord. So how do you find radical axis? Same, S1 minus S2 equal to 0. This is the proof. And what is radical axis? Locus of point from which tangents drawn to two circles are of equal length. Do remember guys, important concept. Some important points here will not go into proof and all, you can just see them. Radical axis is perpendicular to line joining C1, C2. You can verify yourself, but no need. Concentric circles don't have radical axis because if two circles are concentric, you can never draw tangent which will be of equal length. You can check that also. Third, locus of center of third circle which intersect circle 1 and circle 2 both orthogonally is radical axis. So if you're looking for a circle which intersect both circle 1 and circle 2 orthogonally, its center of circle will always lie on the radical axis. You can prove this thing easily guys, see. Let h comma k be the center of circle intersecting s equal to 0 and s1 equal to 0 orthogonally. Now, the radical axis will be s minus s1 equal to 0. So, let be 2g minus g1x plus 2f minus f1 by equal to c1 minus c. Let r is the radius of third circle. So, then h plus g square plus k plus f square will be r square plus g square plus f square minus c. Using that c1 c2 square equal to r1 square plus r2 square here. Same for the second circle, h plus g1 square plus k plus f1 square equal to r square plus g1 square plus f1 square minus c. When you subtract them, you get 2g minus 2g minus g1h plus 2f minus f1k equal to c1 minus c. You will see it is nothing but if you put h comma k is this thing, which was radical axis of ss1. That means h comma k lie on the radical axis of ss1, s and s1. Like I told you, these properties and all hardly we use. This is the definition of radical axis, you must remember. Uh, but this third one, yeah, I have seen some problem on this thing, so do remember this third one. Locus of center of third circle, which intersects circle 1 and circle 2 both orthogonally, is radical axis. Okay, guys, one or two last things here. Radical center. What is radical center? Again, not in syllabus, just for the sake of completion, I'm telling you. So we have three circles, S1 equal to 0, S2 equal to 0, S3 equal to 0. You can find their radical axis pairwise. What you will observe, all three radical axes will be concurrent at a point. That point will be called as radical center. All three radical axes will pass through same point, that will be called as radical center. If you want to find this point, you can just find radical axes of pairwise, let us say for this and this, then find their point of intersection. Okay, not very important thing. And again, I have seen some problem they ask in Arana papers based upon this. They will give you three circles. This is like all three circles are touching each other externally. Now find the radius of the fourth circle, a small circle which is touching all of them externally and lie between this space here. So if the radius of these three circles are A, B, C, the radius of the fourth circle will be 1 by R. R is the where R is radius of fourth circle. So we have this relation 1 by R will be 1 by A plus 1 by B plus 1 by C plus 2 times root of 1 by AB plus 1 by AC plus 1 by BC. Okay, no need to go into proof and all. If they ask this kind of thing, directly can answer this. Okay, guys, so that is all about the circles theory. Make sure you understand all the points, make short notes, and then in the next class, we'll discuss the problems. All the problems, guys, you must attempt first and then look into the solution. They will strengthen your concepts. Because theory is just the 15% of the part. How to apply that theory to solve problem will be the main challenge. Okay, guys, bye.